I think we can start. Thank you so much for your attendance. Today's webinar is about teaching ROS with riders, and we are going to go over a case study with Izmir University of Economics. Apologies for the typo. The real name is Izmir University of Economics. You can find in that way on the web. So, as Professor Gazihan Alankuş, we are welcome here. We are going to together discuss about how about his experience teaching ROS with riders. So, I would like to just do a small agenda. I would like to explain for you who has the first experience with riders. What is riders at all? And then I would like to ask to share his experience on robotics education to Professor Alankuş. And then we're going to discuss several topics: why teaching with riders usage. And then finally, I would like to invite you to our ambassador program, and I will give you some details about that. So since our foundation, we have did a lot of progress. So Riders is a platform which enables robotics education by giving courses or organizing competitions. And we have organized with Maker Faire, a robotics virtual and global robotics competition. We are collaborating with F110, is one of the largest robotics community in the world, together a competition. We are also organizing right now with World Robot Olympiads, and we are partnering with Google for Education, and we are a member of AWS at Start. And in order to explain everything much more clear, I would like to give the story of the company. Basically, ACROM, the name of our company, is coming from an acronym, is abbreviation of Accessible Robotics Mechatronics. Our vision and mission is basically to make robotics education more accessible. And we are providing, in that sense, since 2014, platforms with hardware, with software and educational content to academia, where the professors and lab teachers can teach robotics and automatic control, which are very related to each other in their labs, in their courses. And but the world is moving towards to more complicated and sophisticated systems, where artificial intelligence, machine learning, and more connected devices are coming to play. And for this reason, as an evolving company, we have decided to increase our reach, and we have developed a platform which is a cloud-based robotics development platform, which we call Riders. The name of Riders is actually coming from ride, and the ride is basically an IDE for robotics IDE, and the community using ride we call Riders. So this is a community-driven platform. I would like to mention, you can create projects, you can create courses, you can have projects you can work on, and you can organize competitions between your classes, between the schools or universities, or between the departments. Any type of them is available. So the mission is making robotics education more accessible, but in consideration with the spectrum of STEM. The spectrum of STEM is covering now more advanced studies like AI and machine learning. So in that sense, we need to provide platforms which make also these studies much more available. So Riders is an online robotics IDE in that sense, with tools where you can integrate robots, environments, you can create courses from projects, you can create assessments, and you can organize competitions for students, for robotics enthusiasts, and developers. There are a couple of scenes that I'm showing, like, for example, from an electric car, where researchers are studying reinforcement learning, a drone competition where through image processing with the camera of the robot should move to the numbers. And there are also like swarm robotics, where a group of robots is organized for accomplishing a task together. And there are manipulators. All types of robots are available. And we have done many competitions until now, and I can say that the contestants and the students and also the teachers were highly excited about our competitions. I will give you some more details about this. We have now opened a league, robotics league, where we have right now two categories. One of them is the line follower league, and the second of them is drone flying league. And in those concepts, you use your skills in autonomous robotics and trying to accomplish competition with the fastest time. For example, here in this case, there is a drone running to the circles, and every indicator gives you a sign where you should move. For example, in this case, you should turn right, and then you should follow to the left. This algorithm right now is only detecting the red ones and then turns on the left. But this is just for people to start. But then you can increase your score. As you can see, the score is calculating afterwards and complete markers. So there's a jury, which is an algorithm. So that we have the objectiveness also in those competitions. Another competition is right now going on is line follower in the line follower league, and you are seeing the track. There are red, green, and blue lines which you can select so that you can optimize your path in that sense. And we have when you open this competition, it's completely free to join, by the way. And you can right away go to riders.ai, and once you just sign up, you can reach to the competitions, open it, and then you will see this algorithm. This is the baseline, and then you can improve it to be the best. So how it really works in that sense, that would like to share the line follower league leaderboard right now. In the January, Walter Padawan was the winner of the both drone flying and line follower categories. And there are many contestants. So please, you are seeing the link below. Please visit our website and join to our competitions. And it will be a nice experience for you or for your students. They can try their skill set in autonomous robotics. So after giving this intro, I would like to first introduce you Assistant Professor Gazihan Alankuş. He's a PhD in computer science. He has accomplished his PhD in Washington University in St. Louis. And during his graduate studies, he conducted research on human-computer interaction, computer graphics, robotics, and wireless sensor networks. And since June 2012, Professor Alankuş has been teaching classes, conducting research about computer games, human-computer interaction, computer graphics, and mechatronics in Izmir University of Economics. After this introduction, I would like to invite Professor Alankuş. Hello, Professor Alankuş, how are you today?
I'm good. Thank you for having me. How are you?
Thank you so much. Thank you for participating and sharing your experiences in our webinar. I think this will be very helpful for our attendees. So I would like to start with some initial questions about you had this semester, in the last semester, a course which is called Introduction to ROS, Robot Operating System. How was your experience in general? I mean, not about, there was a time of pandemic and it was very difficult. I can definitely understand. can you share your experience a little about this?
Yeah, with the pandemic, everything is different than before. But this was also the first time that I taught this course. So it was, I didn't have a face-to-face one to compare to. So whenever you teach a course for the first time, it's always difficult. You're preparing new materials. You
Right.
realize you don't know some details yourself, and you learn it. You master the material, and then teach students, see how they are receiving it, adjust your plans accordingly. So it was a bumpy ride, but I'm happy overall.
Perfect, excellent. So when we talk about specifically about a ROS course, there are a couple of instruments that students need to have, like for example installation, etc. Can you explain a little about that?
Yeah, so I did use ROS before in my research, and yeah, when we decided that I was going to offer this course to undergraduate students, the first thing that hit me was, oh man, how am I going to get them to do all the tricks that I was doing in Linux? And I had like a couple of weeks planned to give them some Linux experience. So that was the main challenge that I was expecting. And also,
Yes.
I used a certain portion of ROS. I didn't know all the, breadth of it. So I was also learning and getting
Yes.
prepared for the class. So there were multiple challenges for me at the beginning.
I had the same challenges as well. Whenever I try to provide them, you need to do the installation, and everything must be in the right connection, and everything should match each other, and that was a great challenge. So, but in that sense, how riders helped you to solve such a problem on the student's end?
Yeah, so if Riders wasn't there, the plan was to get them to install Linux and show them how the terminal works, etc. All those tricks, where you write code, how you manage your code. How I was going to like figure out an IDE to use and tell them that not everything works as perfect as you would expect from an IDE, because that was my experience before when I was I like IDEs. I'm used to using IDEs in other contexts. And when I was using ROS in my research, I had some issues about that too. Like I was trying to make it, be friendly as a programmer to me, but it was difficult for me. But then when I first heard about Riders, there's an IDE. It's all in the cloud. You don't have to install anything. So those were all very good points. And I was really happy that there was such a product out there, because the alternative is, like I said, a lot of command line hackery that you're supposed to teach undergraduate students. So in that sense, having an IDE on the cloud was, I didn't think twice. I said, let's use this in the course, and I'm glad we did.
Excellent. So Riders is basically opens a computer in the cloud once you open a project, and it is operating system independent. It is browser independent. You can just with an internet connection and a web browser, you can reach directly to a Riders project. And also, I would like to mention that the CPU, RAM, or storage is not a matter at all. So any computer can, with an internet connection, can access to Riders projects.
Yeah, so I'd like to say, so ROS is a great piece of software, right? It has all those modules that make robots tick, let's say. But the assumption is that you are also like a hacker. You know what you're doing. It's on Linux. Like undergraduate students aren't at that level. So you're either supposed to not use ROS, use something that's watered down, that's simpler, or if you're going to use ROS, like the prerequisites are, you get them to install Linux or get a Raspberry Pi or something and connect to it. And then understand Python programming, understand how these build systems, etc. work, and then find your way around in the command line, etc. So there's a prerequisite for those students to learn before they can do anything in ROS. But
Correct.
with riders, it was just you open up a website, it's all there for you. You're connected to a remote computer almost, and then it's all prepared for you. You just click a bunch of things, write some code, press play, and it works. So that was a very different experience.
Exactly. Exactly. So, for example, when learning ROS, you need to understand about the how to write a launch file in the beginning, or how to create a YAML file, and then how to combine everything, how to call a simulation from the launch file, and how to provide a message. In Riders, we have tried to combine everything into an IDE where you can find almost everything on place. With an integrated simulation, with directly starting a ROS core combined with the simulation platform, so that it is much more easier to start.
I agree.
So can we say in that sense, Riders saves some time? I remember when we were first talking, the first two lectures should be about installing ROS on Linux. Then we just said, okay, we're not going to do this because we have that, right?
Yeah. Instead, I just showed them where the terminal is in Riders, and then because every now and then they would need to go to the terminal if necessary. So I did give them some Linux primer, but it was much smoother. By the way, there's this terminal window down here. You can use it, but no setups, no nothing like that. It was the learning curve, the beginning for the beginners. The barrier to entry is very low when you're using Riders.
Yeah, thank you. So I would like to talk about what type of lessons you had. And I have also a picture here about the course, some of the lessons like ROS environment and concepts. What was the general syllabus of the course that you have taught in this semester?
Yeah, so we began with learning about ROS in a conceptual way, how to think about these robots, how do they work. There are multiple computer pieces that are interacting with each other. They need to be messaging each other. So a lot of time we spent on understanding these nodes, this distributed computing system, and how you should be coordinating them through messages and services. So that was the first bulk of the course. And then, as we went into more developing these nodes, I showed them some extra things that ROS can do. And then once we figured those out, we started to play with the gazebo simulations that was already in Riders for us, thankfully. So in gazebo, we had the 3D world, and then the robot is set up for you, and you're supposed to use the robot in a simulation. Kind of like if you have a real robot, now you write code for it. You do it here. Yeah, this is from our course.
Yeah, I made a couple of summary of those. Yeah.
Nice. Yeah. So it was good. It was very useful. We couldn't go to things like localization. We did some mapping here with your help. But I think overall the goal was to, these are undergraduate students who don't have a lot of programming experience. The goal was to, make them aware of ROS, show them tricks, make them capable in this environment, so that in the fourth year courses, when they do the actual projects, they can be the person in the group who is doing the ROS stuff in the project.
Maybe in the next semesters, there are now also contents for mapping and localization that you can freely use in your courses. So that it will be more content rich from the content perspective. So would like to ask about some questions about the experience. How was the experience using Riders? Would like to mention one important thing to the audience. Alankuş asked us if I can have a dashboard where I can see the students and how much hours they spent on what course, and if I can see some details about their history, about what they have coded, and if you can keep the history so that I can understand securely if they really worked on that or not. So according to the guidance and directives, Professor Alankuş, he has a lot of effort here by guiding us, I must say. We have prepared something which he couldn't use in the semester, but hopefully in the next semester. Can you tell us why it was important so that we can talk about this more?
Yeah, so anybody who taught a course realizes that, oh, now I need to find if anybody cheated or something like that. Because you give homeworks to students, some of them, well, a lot of them do it, with their own effort. But if there are some people who are not doing it with their own efforts, we want to pick them out because you want to be fair to everybody. And something that I didn't think of initially is that they are coming to our computer to use this system, right? They are not using their own computers; they are using our cloud system. And I reached out to you saying that, hey, in Visual Studio Code there are these plugins, etc. We talked about some of the technical details, but the fact that they are in your arena, they are working on your computers, helped us, do all these things, track them. Get the local history. If they did it step by step, you can see step by step progression of their project, or versus blank project, perfect project. So that's obviously copy paste from somebody else. So we could tell that.
Right. So the security is, especially I think in online education, is a still unsolved problem. I mean, you can provide some features and these can be as good as possible, but I think it is still some sort of unsolved because there are always many ways. But if you can really narrow possibilities to a certain space, I think this can help at least for the health of the course and for the grades. And about the task assignments, how did you manage the task assignments in this course? What have you, what type of strategy you have chosen? Can you explain a little about this to us?
Yeah, so during the lectures, I did a lot of live coding in front of the students. I shared my screen and they watched me do things. And then I prepared for them another project, or sometimes in one homework, I even said, okay, I did something in the class and then you change it this way as the homework. So it was programming assignments for them. And in it, we could write notes, comments, to do items like that, like the one you're showing. But the idea was that there is something that's kind of working or that's almost blank, but not completely blank because it's difficult for the undergraduate student. So it's you have the boilerplate necessary things there, the interesting bits they are supposed to add. Whatever we learned during the lecture, they are supposed to apply on that project. So it was really easy for me to just create a project here and tell them to fork it and then later share it with me, and no passing files around, no saying, oh, it was working on my computer kind of situation. So it was, so they created these groups and shared it with me so I could see their projects directly.
So thank you for sharing this. This was your dashboard. Basically, for every student, you opened a group, right? When you gave them a homework and you asked them to fork their homework to their own group. Is that the way that you have done?
Yeah, I actually told them to create the project groups themselves. So I even delegated that work to them too. So it was their job to fork the homework to this group, and then they could save different versions of it. But because they could also keep working on it after they submitted, and in the submission, we could see the dates, before the homework date, whichever one they saved as that version. There's version control here. They could continue working on it if they wanted. They could create new versions, but we went to that version before the homework deadline and then graded that one. And me and my assistant, course assistant, every student gave access to us, and we were able to just grade it very easily.
So with that version, you can also see the published date, and so that you can understand that if they exceeded the deadline or not. and you can open from any version on Riders. So, and then you can reach out the homework content of the student, basically. And by they are doing, as mentioned, we have such a GitHub structure where you can fork a project into a group and into your personal space, and all types of possibilities are in that sense available. And
there are these versions, and also in those versions you can see their day-to-day activity with the local history plugin. So
exactly, that was very nice that you mentioned. So once we get into that version, we can see the day-to-day activities of what they have done. Is that correct?
Yeah. It automatically saves these versions as they are working.
It automatically saves versions, and this is important for the security and what they have done, or any plagiarism or any copying and pasting. You can directly see. That's great. So would like to ask, I mean, we are continuously in communication with you definitely, but I would like the audience also hear what type of requests you may have for the future. For example, in the next semester, you are going to open the course again, as you described. What type of things might be very nice from your end, so that we can continue to develop?
So first of all, I would like to thank you for being very responsive throughout the semester. Whenever I had an issue, in the AM hours, you were like responding, working, fixing projects for us. So that was really useful. Thank you very much. And
our pleasure.
I'm sure you told me that you're working on some features that I was excited about. So one thing we wanted to do, well, if we had time, we were going to try get this code out and put it on an actual robot. A lot of students were excited about that. We didn't have time to do that, but I heard you have a strategy to gradually include the robot into this, which would be really nice.
So the export possibility, you can still export, but it is a little tricky right now. But there will be an export option where you can completely export the project and then deploy to hardware. This will be available. In addition to that, about the hardware integration, you will be able to directly deploy some code on the hardware end, and you can create a cloud-connected robot platform, as I mentioned earlier. I think this is one of the nicest things. You can connect as many as possible devices, and you can create, for example, a swarm application or very complicated application together with those devices. And that can be very interesting. In addition to that, it's not stating here, Professor Alankuş asked us, we are providing some shortcuts so that students, especially the beginners, can easily start a project on ROS and with ROS and Gazebo. But Professor Alankuş asked us if students can see, once they click, for example, to start, what's going on behind the scenes on the terminal, which will be very essential. So basically the transparency. And IDE is going to be very transparent because every feature we add will have some correspondent terminal response and terminal output. This will be available very, very soon. I mean, before the next semester, definitely, I can tell. And we are planning to provide a local IDE to work when you're offline. And as content developers as well, we are developing competitions for the community, for students. Developing robots and environments is really not an easy thing, like writing an URDF file or implementing an SDF file for Gazebo especially is something that takes a lot of time. And these feature will be also available in the next months. So I would like to also give this information from here. Thank you so much, Professor Alankuş. It was very helpful, not only in this webinar, but working with you was very helpful for us. And we have developed things with your guidance. That was priceless, and that was very valuable for us. And thank you for attending into this webinar and answering our questions. Thank you so much.
My pleasure. We will keep using riders in our lectures, and I'm excited to hear that these new features are also being planned. So that's going to be even better for us. Thank you.
That's something very great to hear, because once you decided to use in the next semester, I said to myself, okay, we are doing something right. So that was very, very important for me. Thank you so much for sharing this thought as well. So I would like to summarize the key takeaways from this webinar. Basically, teaching ROS with riders solves many problems in terms of an online course and installations and other. As a teacher, you can concentrate more on the course than tools and installations, and problems may be happening during the installation of some of the students. And we provide you student data, like how much hours students have spent. We are sharing with you the local history, so you can check any type of plagiarism or copying and pasting, so that you can grade the students with more justice, I can say. And students can share their homework privately with you. You can check if the homework has been finished until the deadline, and you can check from the history if there's any plagiarism or cheating. And in addition to that, we provide you an IDE which combines everything from the simulation and until the notes. We connect very complicated paradigms of ROS, like notes, topics, services, simulation, and others into a very clean IDE, which we call RIDE, or Robotics IDE. I would like to ask you to try riders by maybe opening some of our competitions when you sign up. This can be very helpful to understand how riders works in that sense. So right now, 7 universities use riders platform, both in teaching and some of them also working in the research domain. But we are providing also access to high schools, because it is a very hot topic right now. Maybe the best way to understand the career path and understand the enablement of interest to STEM is maybe going through the high school learning robotics. And we are providing also competitions for high schools and providing some curriculums as well. So it has been since we first launched Riders in May 2020. It's been almost a year, but we have a great experience from the students, from the teachers, and from all our partners. And if you want to be our ambassador, please contact us. We can work and collaborate together. If you can help our expansion worldwide, this can help us a lot as a startup, and we can collaborate in that sense in all possible ways. So I would like to ask you also to follow us and stay connected. And you can find us on our website, riders.ai/about, or you can find, you can reach us over Instagram, Twitter, almost all social media channels. We are putting every time our videos of our competitions, etc., some interesting projects and some interviews to our YouTube channel. I suggest you to watch those videos as well. So thank you very much for your attendance. If you have any questions.